Video number 3. Okay, we're 75% complete. Okay, this video I think is one of the most important videos in the entire series because I am going to be interacting with the smart contract from the web application, which means that we are going to be connecting the smart contract into the web front end. That's how we send the information into the blockchain. We need to do a hook, but it's more than a hook. We need to do that link between the blockchain and the web application. And in order for us to do that, we need to export the smart contract API. The API, I call it the Higgins boson of the blockchain. It's basically that information that we are going to obtain from the smart contract. Once we compile the smart contract, we are going to be generating the contract API, the application binary interface. We obtain that information from the smart contract. Hey, and that's how the web front end knows what functions do I have configured on the smart contract, what I wrote in that smart contract, what's the name of those functions. So when I code the JavaScript function to send my request onto the blockchain, I need to tell the web front end, hey, by the way, that function is on the smart contract, okay? So that's how we tell the web front end that I have a function to create the profile, I have a function to update the profile, I have another function to update the picture, etc. So once we're writing that, once we're coding all that beautiful language in the web application, NextJS is gonna say, what the hell is this guy talking about? Because I don't have any clue what create profile means. It's not in my modules. Hold on, NextJS. Hold on, React. Hold on. I am going to give you the function and what are you going to do with it? It's the contract API. With the API, we're basically telling the web front end, point here, okay? We will use EthersJS to do the calls into the blockchain, okay? So what we're gonna do, we're gonna use that JS library to interact with the smart contract, and we need to provide Ethers, the API, along with the contract address and the wallet that will be in charge of executing the functions. This is when we are going to be designating an updater wallet. Basically, what I did in the last video was I developed a role called updater role. So with that role, I am going to avoid anyone from making calls into that smart contract and sending information that we don't want. We don't want anyone from talking to the smart contract and dropping garbage into the database and then destroying the application, right? We don't want that. We want to definitely control who can make those calls. So for that, we are going to designate a wallet that will be stored inside the web front end to do those calls. But here's the catch. I am doing this video, just FYI, I am doing this video importing the private key into the web front end. That is not a good recommendation for production purposes, because if I go and press F12 and look at the browser console, I remember with front end, it's client rendered, meaning that the end user who connected to that website is going to have the full-blown front end code rendered and available in the console, so they can easily retrieve the private key. I am thinking the following: after we're done with this series, we are going to be building a backend. We're going to be doing the middleware and the backend, which means that I will have a production-ready application with a backend storing all those private keys and all the functions that we don't want the front end to deal with. We want to send those functions to the backend. For this demonstration, I am going to do it in the web front end because it still is Java. You can use JavaScript in the web front end to do those calls, but ideally those functions that are going to be interacting with IPFS, all that information is sensitive. So you don't want that to be generated in the web front end, you want that generated in the back end, okay? So we will work on that, don't worry. Okay, so I am doing that. We'll import the smart contract. After we deploy the smart contract, we'll import the contract API. We'll add this onto the web front end. We will test the smart contract by creating a bogus user profile. So the first function that I'm going to be writing in the web front end is going to be to obtain the information that we just stored in the smart contract. So we know that we can do the interaction between the web front end and the blockchain. Awesome. But then there's another item that is a bonus. I am going to be configuring an IPFS node. We will build our own local IPFS node. Okay, there's ways to interact with IPFS. You can go with a public gateway that will take care of your requests, but those are very limited, okay? You can build your own node, which means that I will have a local server or a local node running in my infrastructure that I can call locally. And that node will take care of sending those calls up into the IPFS blockchain. Or there's a third option, which means that I can use a dedicated gateway like Pinata. With Pinata, I can actually send the request to a dedicated gateway that no one else can touch but you, that you will have constant dedicated bandwidth, and you are going to make this application more resilient, more redundant. Remember, once you rely on an application that it's going to store all that sensitive information, and you don't want the application to go down or suffer an outage. Either two ways, you deploy your node, but remember, you need redundancy on that, which means that you are not going to deploy a single node, because if that node goes down, you're dead in the water. What you want to do, you deploy an IPFS cluster with basically a bunch of nodes, or at least 4 nodes in the cluster, and then you talk to the cluster address, and then the cluster will just decide to distribute the calls into your nodes. Or an easier approach, just get an IPFS Pinata gateway. That's it. With an IPFS gateway, dedicated gateway and Pinata, you just send that. They'll take care of it. Okay, you're paying a service fee, but trust me, less stuff that you need to worry about. Okay, so I'm going to show you that, because this is what I'm here for. I'm here for you to learn as we go along. Okay, all right. So we're done with that. I am done with talking bull crap. No, just kidding. I am done with a lot of talking. You can see that I love talking. Like, that's me. I talk. I'm right here in my studio, and I'm literally talking alone. But this is what I love. This is what I do. I am learning a lot. Like, by making videos, this is how I learn. Believe it or not, you will be surprised. I am going to do another video. You know what? I am going to do a live. And I'm going to tell you how I started here. You're going to be surprised, and you're not going to believe it. Like, I'm telling you, you're not going to believe how did I get here. Like, it's a very interesting journey. Okay, so I think it's going to give you a lot of motivation. Wow, yeah, it's insane. It's insane, because I started this channel a year ago. Exactly 1 year ago. If you look at my about page, it's January 18, 2022, okay? And now it's about to be January 18. Like, right now I'm recording it. Today is January 14. And wow, I started realizing, like, in 1 year, a lot of stuff has been done in this channel. And oh my God, it's insane. It's insane. Learning Web3, it's the best investment you can make right now. It is the best investment. It's either Web3 or data science. Blech. No, my coding has to be dynamic, meaning that I need to interact with all sides of the equation. Like, I cannot just focus on one thing. I am a strong believer in blockchain. It's not that I think, I know blockchain will be the future. The functions, everything that I can do with blockchain is insane, okay? Anyway, I'm not gonna continue talking. You saw, I keep talking. Like, I don't know, that's me. I love it, okay? All right, let's go ahead and let's make this happen. Let's build the IPFS node and gateway. We will have both features. We'll have the IPFS node, so then we can pin files, okay? So we can send the data that we need to store for those user accounts. And let's also use the local node as our gateway, so then we can retrieve the files. We can read from our local node, so the interaction with the application is going to be very fast, okay? It's going to be the local node, okay? So what I'm going to do now, I'm going to deploy the IPFS node, and we'll go from there, okay? So the first thing I'm going to do, let's go to GitHub, but in this case, I'm going to go to Google, and then what I'm going to do, I am going to look for IPFS GitHub, okay? And we want to take a look at the IPFS desktop. That's what you want to look for. Okay. I am going to install from the source. We want to install this from the source, which means that I have to just do a git clone, right? And then we'll go ahead and proceed to do this step right here. We're just going to go over the directory and run the npm commands, and off we go. Okay. Okay, now what I'm going to do, I'm just going to paste git clone, and we are obtaining the IPFS repo. Once we do this, then we'll run the commands that we see here. Okay, awesome, it's done. So now what I need to do, I got to navigate into the folder. Okay, so I am in the folder. Now what I have to do, npm CI, we'll run through that, and we'll go from there. It's done. Now we need to run npm run build. Okay. Okay. Now we have to do the following. Now what I have to do is start the node, npm start. Okay. And once that's up, we should see the web interface as well. It's just going to open a web interface. There we go. Looking good. Okay. So we have the node up and running. Now we need to enable the API so that we can call this API and send the files from our application. And this node can be used for many applications, because what we're going to do in NextJS, I am going to install the IPFS HTTP client. And from there, I can point to this server. So what I have to do, I have to obtain the IP of this machine, and then I can point myself and send the data to this local node, okay? So the first thing I have to do, I have to go under settings, and we're going to scroll down, okay? And under the configuration itself, we have to do the following. We have to allow the HTTP headers for get and post and put, okay? So we need to allow the node to accept API fetch requests. And in this case, allow the IPFS HTTP client to call or talk or interact with this node, okay? So I have to add those parameters here. And then also I have to make sure that I can access the API gateway from anywhere, okay? Right now, the address has been binded to the link local interface, or in this case, the local machine, the machine itself, the node. So I can only interact if I'm inside the same node, and we don't want that. We want to be able to interact from other servers, okay? So what I'm going to do, I am going to change this to be the IP of the node, so then we can talk to that IP, okay? So very simple, all I have to do is ipconfig. So I'm just going to go ipconfig. If you're running Linux, it's ifconfig, okay? So in this case, my IP is 10.10.20.32. So what I'm going to do here, I am going to replace this value with 10.10.20.32. Okay, so I'm going to do 10.10.20.32. And then I'm going to go ahead and do the same 10.10.20.32. Okay. And finally here, I have to enable this API to be accessed from the Next.js frontend. Okay. So what I'm going to do, I am going to add headers. The first header that I have to add is going to be the access. I'm going to show you right now. I am going to add the access control allow methods. Okay. So by doing this, okay, I'm just going to add this here. Perfect. So by doing this, I am going to tell this node, hey, I want you to accept put request, right? We also want the node to accept get request, so then we can read the data, and post requests, so we can insert data or inject data into the node, okay? Cool. So what I have to do, as a matter of fact, I did something right here. I'm just gonna, this should be brackets. Okay, cool. I think we should be good now. Okay, perfect. Now we're good. So it's basically the braces, and then this is the bracket, okay? Awesome. So what I got to do a comma, and then now I have to allow CORS. It's to protect which HTTP or which sources can originate traffic into this HTTP API. So in this case, I need to, specify certain IPs that are going to talk to the node that I have to specify it here. Else, I can just do wildcard, which is basically the asterisk, and it will just allow all. For this demonstration, I'm going to do that. But when you deploy this in production, you want to make sure that you tied this to only the application server IPs. That's it, okay? All right, so let me go ahead and do that. So what I'm going to do, I am going to create the other header, which in this case is going to be access control allow origin, okay? So with this, I can now specify the parameter. So the parameter is going to be a wildcard. So it's basically the asterisk. Anything that matches that, it should be good to go. And what I'm going to do, I'm just going to put a comma here. Not necessarily. This will be the only item that I need to specify. And yeah, that looks good. There's nothing else that I need. And I got the 2 IPs. Make sure that you change the 2 IPs, okay? And once you're done with that, you are going to just save. And by default, it adds the web UI IPFS IO, and then it adds this address. Again, we are specifying asterisk right here, so you should not worry about it. As long as you have, obviously, the IP address of the node, and then you have the allow methods, so then we can do the post and the CORS. So if we are allowing CORS, and this is basically matching everything, which will be good, okay? So let's go ahead and save. That looks good. Now, I need to restart the IPFS process. So if I go into, you're not going to see it here, but basically on my taskbar, I can actually do it. So I'm just going to click restart. As a matter of fact, let me just show it to you guys to make sure that you can see it. So we're just going to click restart. Okay, we'll just grab the icon right here, restart, and that should restart the node. Okay, perfect. It has restarted, so we should be good. Let me confirm that I got all the configs on the file. Perfect. Yeah, everything looks good. Awesome. Okay, so we're good with this. Now let's test to make sure that the IPFS is able to receive requests, and we'll go from there. So what I'm going to do, I'm just going to create a quick Node.js file so that we can just send some data and make sure that we can retrieve the data. Okay. So what I'm going to do, I am going to open another PowerShell because we need to leave that open. I am going to make a dir. I'm going to create a directory called node. Okay. I'm going to do a cd node, and then I am going to do the following. I need to install the HTTP client, the IPFS HTTP client. So the way that I'm going to do this is by doing npm I IPFS HTTP client. Okay. So by doing this, I can now use this client to then talk via the API. Okay. Done. Now, what I need to do, I got to open Visual Studio Code. So let me go ahead and do that. Let me navigate to this node folder. So this is the Node.js folder that I just made. And now you already see some, the package JSON and the node modules. That's because I install IPFS client, the HTTP client. Okay. So now I am going to create a new file. This will be the test IPFS just to validate that it's working. Okay. We're just going to call this JS. Okay. So the first thing I got to do, I am going to be importing the IPFS HTTP client into the script. Okay, so I'm just going to import create, right? And yeah, we just need, it's binding it to the source, but all I need is literally this. So that should be it. Constant. Now let's build a constant that will be used to point to the node IP address, because we need to point our application to the node so that we can interact with IPFS. Okay, so what I'm going to do, I'm going to type client. Okay, and then what I'm going to do, I am going to invoke create, which we just imported that. Okay, and I am going to then point to where? I am going to point to the address. So it's going to be HTTP. What's the IP address of the server where my IPFS node is running, it's 32, and then the port, it's 5001. How do we know this? Let's go back onto the IPFS, and you can see right here, I don't know if you can see it right here, 5001. If I go to status, I hope that I can see the port. Here we go, the API. So we need to make sure that we can reach this API address. The port is 5001, okay? Cool, so we got that. 5001, awesome. Now we got the client, which it's basically going to send my instructions to that API address. That's basically what it's doing, okay? Now we need to send some data. Let's send a simple text to make sure that we, number one, obtain a CID. That is the most important thing. We need to obtain the CID so that we can send that CID to the smart contract and reference that CID to the user account, okay? That is super important, okay? So constant, let's call this data. I'm just gonna name it data. What I'm gonna do, I'm going to say await, and I'm going to say client, which is basically pointing to the IPFS URL or the address of the API, and then I'm gonna do the instruction, which is add, okay? This is inside the module, IPFS HTTP client. You have a function called add, or a property called add, okay? And inside here, this is where we can specify, or we can type the data. Like in this case, I can just type a text. I can say, hey, this is Net2Dev amazing Web3 user profile tutorial, okay? Awesome, so we are going to store that in IPFS. And at the end, I want to make sure that I obtain the CID so that we can access this data, okay? So I'm just gonna do a quick console log, and I'm gonna type data, okay? So we're just invoking that. I'm gonna Control S, and now let's go on the shell and try to run it, okay? So if I do there, it's gonna be there, okay? So now I'm just gonna type node test IPFS. Okay, and there seems to be an error. Oh, yeah, ES module. Okay, so the way that Node.js, I am going to have a separate video to start working with the backend, and it's going to be Node.js. So I have to specify that I'm going to be loading modules using ES format. So not a problem. It's very simple. What I have to do, I have to add this into the package.json, and that should take care of it. Okay, so I'm just going to copy this. I'm going to go to package.json. And then I'm just gonna do a comma right here, and then I'm gonna paste this right there. That's all you have to do. Control S, you're done. Let's try it again. Okay, and see if we're lucky. Beautiful, awesome. Now we have the CID. We are effectively talking to our local IPFS node, okay? Cool. Let me copy this address, and let's confirm that we can see the data, that we can read that information that we provided in that script, okay? So what I'm going to do, I want to make sure that I am copying this CID value. And how do you access the local IPFS gateway? Because remember, the API is to send the information or to upload data into IPFS. And then the gateway is to read the data, is to retrieve the values, okay? So what I have to do, I have to point to the gateway path, and then the gateway is also running in the node. So what I have to do, I have to determine what the gateway address is, okay? So you can see it right here. You can see gateway, right? What's my gateway? It's HTTP, comma, and colon, and then /, and then the IP address, and the port it's 8080, okay? That's why I told you at the beginning of the video that you need to make sure that you change the gateway IP from pointing locally to the IP of the server, so then you can access this from the outside, okay? So from any other application, any other server, you can point to the server IP as long as it's reachable on the local network, and you can you can upload files into IPFS. Very cool, okay? So what I want to do now, I am going to go back, and now that I know that it's 8080, I can actually do this. I can do HTTP / then the IP address of the node, which is 32. I'm going to do 8080 what? IPFS, and then we are going to paste that CID that we just obtained, okay? We'll press enter, boom, beautiful, okay? So now you have a fully functional IPFS node that you can use as a gateway or to upload files. Now I can go ahead and import, or I can send all my user accounts into IPFS using my local node, okay? Very important. This is a local node, which means that if it's down, your application is down. If the node is down and the front end is pointing to this node, guess what's going to happen? This is why I will strongly recommend to subscribe to a dedicated IPFS gateway with Piñata. So with Piñata, you then point your application to a gateway that is going to be always on. That's the guarantee. It's going to be always on. It's going to be dedicated for you and you only. And then you can upload and then interact with your application, okay? Else, this is another way to do it. You can do a local node, but then keep in mind that you should have this in a cluster, meaning that you must have a couple of nodes and you're going to have a cluster address. Remember the address that I typed here in the browser? That address is the local node. When you have a cluster, when you're basically building a group of IPFS nodes and they're all communicating and interacting within each other, is an IPFS cluster. That will generate a cluster address, or you'll have a cluster address that you can point to, and then it will land in either one of those nodes. This is a distributed IPFS cluster. I can use any of the nodes. If one node dies, I still have other nodes available that can process that request. That is redundancy, right? So we need to make sure that we have that in place, okay? But we are good to go. Awesome. Now what I have to do, I have to deploy the smart contract. We are going to deploy the user database smart contract that we built in the previous video. We will just create a bogus account. And finally, the last thing that I have to do in the web front end is make sure that I can populate the information for that bogus account, okay? So I can see the data in the web front end, okay? Let's do it. So let's go ahead and deploy the smart contract. Once we deploy the smart contract, we go ahead and test by sending information to the IPFS node, obtain the CID, and then import the CID into the smart contract. So then we can create that first profile. Okay, let's do it. So what I'm going to do, I'm going to just click raw here and Control-R, Control-C, and let's go to Remix. Okay, I'm just going to paste it right here. And by the way, this is the smart contract that we built in the last video. Okay. So let's go here. I am going to Control-S to compile. Has been compiled. Awesome. Now what I have to do, I have to deploy it. Okay. So what I'm going to do, I want to make sure that I am not going to deploy it in production. Let me switch myself to the Mumbai testnet. And I'm going to use my wallet that I use to deploy the test contracts. And yeah, that looks good. Okay, so let me go ahead and deploy it. Okay. I am going to pay and let's await for that confirmation. Okay, cool. We got confirmation. Awesome. Alrighty. Let's go ahead and do the following. We have to export the contract API. Without the API, we cannot talk to the blockchain. We need to use the API to call the functions that we have configured on the smart contract. Okay. So how you do it? Very simple. Just make sure that you go back into the compiler section, then select the user database smart contract, and then you're going to copy the API. Okay. So we have copied the API. Now we need to open the front end in NextJS. So the front end, we have to open it in Visual Studio Code, and then we are going to create a API file and use that to interact with the smart contract. Okay. So what I have to do right here, I have also the smart contract address, which we need. But first, let's bring the API first. Okay. So what I got to do, open the folder where my front end is currently running. Okay, and let's go ahead now. Remember, that was the first video. We have configured that front end, so it's ready to go. So now what I have to do is number one, let's build a components folder. Okay, so I'm going to create a new folder, and this will be called components. Awesome. We are going to create this new file name is going to be UserDB.json. It's JSON formatted, the ABI, and we're just going to control V, and there you go. We have pasted the contract ABI, and now we should be good to start interacting with the smart contract, okay? So now what I'm going to do, I'm going to control S, and we have this file ready for us. And now what I have to do, I have to install the front-end dependencies. We have to install the Web3 model. This is to interact with the MetaMask wallet. And we also have to install the EthersJS module and the IPFS HTTP client, because remember, we need to interact with the node that we just configured, that we have configured and is ready for us to start using. Okay, let's go. Okay, let me expand the font right here. This is gonna look better if I do this. Okay, awesome. So now let me navigate to the front end project folder, Web3 profiles. Awesome. And this is my project. Okay, so we are going to npm I ethers. Okay, now we are going to install Web3 model and npm I IPFS-HTTP client. Okay, cool. Awesome. So we got all three dependencies. Now we need to import those dependencies into the config file. The config.js is basically a file that we will leverage and use across the entire app. So let me go ahead and build that. And we also have to import, or I would say I have to copy the address of the contract, because we need to tell the front end which contract it's going to be interacting with. Okay, so let's go ahead and do that. Let me copy the address. Okay, so I just copy it from here. And now let's go into the components. Let me create the new file. We are going to create a config.js file. And now we should be good to start here. So what I'm going to do, I am going to type export constant. Let's label this UserDB address. Okay, and this will be the smart contract address. Perfect. Awesome. All right. Okay, and we have to import EthersJS. Okay, and we also have to import the IPFS HTTP client. So let's go ahead and do that. We have to import the action, the property of create, right? We need to specify that we are going to reference this to be IPFS HTTP client from IPFS HTTP client. And there you go. Awesome. All right. Awesome. Cool. So now I can interact the same way that I did with Node.js. I can do it with this front end. Okay. So what I want to do now, I am going to create a constant that I need to export so that I can start working on the front end. This constant, we're going to call this client because this is the IPFS HTTP client. Okay. And what do you think we need to do? We need to invoke IPFS HTTP client because that's the reference to create. And what is create? That is pointing to the URL, the node URL, the node that we configured. Okay, let's go ahead and do that. So I'm just going to open parentheses right here, and we are going to type the full URL name, or in this case IP, which is http:/, and then the IP address is 32, and it's going to be 5001. Cool, awesome. So this is good. And it has been exported, which means that I can use it across the entire app. Okay, now I can invoke client, I can import that, then use it. Okay, cool. We got the smart contract. We're good to go. Now, one thing that I have to import as well, I have to import the ABI because without the ABI, I cannot make any calls to the smart contract. Okay, so I'm just going to import, and let's call this the UserDB ABI. Okay, from what? Components, okay, and then / and there you go. This is the ABI file. Okay, awesome. So now we got the ABI imported. And now what I need to do, I have to tell the front end which RPC address. The RPC address is the HTTP address that we will use to send calls to the blockchain. Because instead of us using a MetaMask wallet, we are going to let the application, in this case, EthersJS, perform all the calls, the Web3 calls in the back, in the background. So there's no need for like connecting MetaMask. It's just going to be used. It's going to be done internally in the app. Okay. All right. So what I'm going to do, I have to create the name, or in this case, the RPC address. So matter of fact, I don't need to. I just need to do constant, and I have to tell, let's label this RPC, and the address will be the RPC address to the Mumbai testnet, because we have deployed this in the Polygon Mumbai testnet. Okay, so I need to find that address. I am going to give you a site that I use that I like a lot, to chainlist.org, and we can find the RPC address for the Mumbai testnet. Okay, so you can click here, include testnets. Let me just expand this so you can see it. Include testnets. Cool. Now what I have to do, I have to scroll down, or I can just search. Okay, perfect. Now if I expand here, I am going to see a couple of RPC addresses. This one works well, the lowest the latency, or the lowest the latency value, the better. Privacy, they're just telling you that they're going to be able to see what data you sent to that RPC. Okay, so let me just copy that address. Now let's go back onto the config file. I'm going to go ahead and paste. And now we can use that address to do the calls internally in the front end. Okay, this doesn't have to do anything with MetaMask. This is internal calls. This is where we are going to use the updater wallet. Remember the role? We now have to designate, and by the way, I have to do that now. We have to designate the wallet that is going to be allowed to perform the functions. And we explain that we need to use a wallet that will have the role, the updater role, so we don't let anyone talk to the smart contract. Okay? All right. Awesome. So what I have to do now, as a matter of fact, I am going to do that right now. Let's go under Remix, and now we can see in the functions, by the way, the functions, we have create profile, we got grant role. This is where we are going to designate the updater role, okay? And then migrate profile, record pay, everything that we talked in the previous video, okay? All right, so what I have to do now, I have to first find the byte 32 value for the updater role. So I want to grant this role to a wallet that we will use to perform the calls, okay? So in this case, I am going to copy this, okay? And we are going to grant role. Let me expand here. It's going to ask me the value, which is what we copy and paste. Now the account. What I need to do, I can designate the same owner, which is already the updater, because remember in the constructor, we set updater role. So I can use that wallet, but ideally you want to have a separate wallet just to do the updater, okay? Because this is the owner wallet. If that wallet gets compromised, then the smart contract gets compromised, okay? Cool. So what I'm going to do, I'm going to switch myself to another wallet. Let's use this wallet to be the updater wallet, okay? So this will be 62. The wallet, starts with 062. I'm going to copy that. I'm going to add this into account. This is the account that I want to grant the role. However, we got to make sure that the wallet that I'm going to use to grant this is the owner wallet, because it's the only wallet that is allowed to do this, okay? So I'm just going to go ahead and transact. Now we should get the prompt. We get the prompt. And we are going to confirm. And once we are done, then we have the updater wallet. I am going to show you what we need to do. We need to now export the private key and then import the key into the front end. Again, this is not something that you should do in production. Like, this is demo. We are going to work with the backend so you can properly store those private keys and protect the application, okay? So what I have to do now that I have the role, I am going to copy the private key. So I'm just going to go in the account details, right? So this is the updater wallet, and I am going to export the private key. And this is the wallet private key. Okay, and paste. And okay, so this is my updater wallet. Awesome. Now that I have the updated wallet, I can build the entire function that will allow me to perform calls into the smart contract and create profiles, update profiles, anything that I want, okay? Let's go ahead and do that. Now, what I have to do, I have to build the provider, okay? So we're just going to type constant provider, okay? And then we are going to say new ethers providers, right? And then it's going to be the JSON RPC provider. There we go. And guess what? This is the address that we want to talk to, the RPC address, okay? So RPC. Cool. Awesome. So I got the RPC. Now I got the RPC binded into the provider. Now I can use provider to build the entire contract call, basically, okay? This will include the provider info, the wallet, and this is the updated wallet, and also the ABI. And this is how we can pack everything into a one-liner. So I just need to invoke contract. So what I'm going to do now, I am going to type constant updater wallet, because now I have to tell Ethers that this is the wallet that you are going to use to perform calls, okay? Updater, I'm just going to type this. It's going to be new, okay? And it's going to be Ethers wallet, but it's all caps. This is the instruction right here. And we are going to type wallet, or you know what? Let's call this updater, so it makes more sense. Updater, wallet, right? And we're just going to say updater. This is the first info that I have to provide. So then Ethers builds this a wallet, and it can use that to perform calls, okay? And then we are going to type provider, okay? So with that, now I have the updater. With the updater, I can now effectively build that one-liner contract call, okay? So what I'm going to do, and this has to be exported, okay? So because I am going to be using this across the entire front end. So I'm going to say export constant, and we are going to call this user contract, right? Equals what? We're going to type new Ethers contract. This is how we build that function. And we are going to provide the values. The first value that I have to provide to build the contract function, so then we can start making calls, is going to be the address of the contract. Obviously, user address. This is the address of the contract, comma. The next value, it's going to be the ABI. The ABI constant that we built, and it's going to be this one right here, UserDB ABI, okay? So we're going to do UserDB ABI, okay? And the last thing that I have to import, guess what? It's the updater. It's the wallet that is going to be allowed to make those calls. There we go. Cool. Awesome. So we have built the entire contract in one liner. Okay, awesome. So now we got the client to interact with IPFS. We got the address itself in case we need to make calls or reference the address somewhere. And then finally, we got the contract function so that we can now start making calls to the functions that we built in the smart contract. Okay, cool. Let me go ahead and Control S. So this is saved. Cool. It's all good to go now. Now let's go ahead and go under the main page. This is the index page, right? And let's go ahead and import that contract. Okay. So I'm gonna do the following. I'm gonna say import what? I am going to import user contract. Remember, this is what we just built in the config file, and now I can use this in the front end. Okay. So this is the index. This is the page that the user has its own profile. I am going to build a function that is going to allow me to obtain the data from the front end and then send that to IPFS. Okay, let's go ahead and do that. So I'm going to do is async. Okay, so we are just opening the default function here. I'm going to say async function create profile. Okay, let's call this create profile. And then I am going to say the following. Check this out. The first thing that I have to tell NextJS is the information where it is going to come from. It's going to come from the HTML input boxes. We're going to be building those input boxes that you saw. I have to obtain that data, and then we have to pass the data into the IPFS node. So then IPFS will, store that for us, okay? So let's do the following. First thing I got to do, check this out. Let me go ahead and run the app, and let's find those values. And let me run the app. npm run def. Okay, cool. Now what I have to do, let me go into the site. This will be 31, I believe. Yes, 31, cool. And here it goes. Beautiful. Okay, so we got the site up and running. Now I have to retrieve the values for first name, last name, username, and email address. Okay, this is the front end. So what I have to do, I have to open the index HTML that we were working with, the index.js file, and let's go to the first value, which is going to be first. Okay, here you go, first. Okay, the input box, the name is first. So you can see it right here, the input first. Okay, now check this out. I am going to call this using HTML DOM, and then I can reference and obtain the value from that. Okay, so check this out. So I'm going to call this ID first. That's how I'm going to obtain whatever the user has input in the HTML front end. So that's one, and then we know that first ID first, that's the first ID. The second ID is last. The username ID is user, okay? And then finally the email ID is email, okay? So check this out. This is very cool. I'm going to create a couple of variables. The first one's going to be, let's call this get first. Let's call this get first, okay? Which is the first name. And now you're going to type a document, right? Get element by what? By ID. That's the ID that we just saw in HTML, okay? And now what I have to do, I have to put in parentheses, what's the ID first? Remember what we saw in HTML? That's the ID, okay? And then dot what? The value of that to string. There you go. Awesome. So basically what it's doing is grabbing that information and passing this as a string, okay? So I am done with this. I am going to copy, and we're going to take advantage of that copy and paste. 2, 3, 4. And then get last, because it's last name, and then we are going to replace this with last. Now we are going to do get user, because it's the username. And now what I'm going to do, I am going to type user. And finally, get email, which is get email. There you go. Awesome. So now we got those variables, okay? Let's test. Let's make sure that I can pass data into this function so that we can import IPFS, the client, and we can send the data to IPFS, okay? Let's go ahead and do that. So what I'm going to do, I'm just going to console log, and let's just pass get first because we're going to know that it's working. Get first, okay? Awesome. And now what I have to do, I have to attach this button somewhere. So I have to attach this button to the front end. So what I'm going to do, there is a button that we can use here, which is the update profile. So let's use the update profile for now, and just to test, to make sure that we can see the log of the first username. Okay, there we go. Here's the update profile. And what I have to do here, I have to tell onClick below the class name inside the button. It's going to say onClick. Right, and we are just going to call the function. The function name is going to be create profile. There you go. We have attached the function to the button. Okay, Control S. Let's go back. And if I press F12, on click, it's a typo. So let me just fix this. There we go. You just refresh to be safe. Let me expand this right here so you can see. Okay, awesome. So if I hit update profile, nothing is going to return because there's nothing in the first name. But guess what? I'm going to type John, update profile, John. Beautiful. So now we know that we're passing HTML into the function. Now we know that we are going to be able to send that user account to IPFS and then obtain the CID and then send that CID to the smart contract, okay? So with that said, let's continue. Now I have to bring the IPFS client so that we can send the data to IPFS, to the node that we just built. Awesome, let's go ahead and do that. So what I have to do, I am going to say the following. Check this out, okay? Pay attention to this one. Let's go back up here. I have to make sure that I don't have any empty strings or empty space. So if the user forgot to type something, I don't want to update IPFS. I want to tell the user if there's something missing, he needs to provide the full fields, right? So what I have to do, I have to say a condition. Let's check if those values of those variables are filled with data, else you're not going to pass, okay? So check this out. I am going to do if, right? And this is how we confirm. If bang get first, okay? And then we'll do the pipe here, right? Double pipe. You have to match this and whatever else I am going to provide. Get last, meaning that I am also requiring that you have get first and get last. Both of them, they have to have data. If I want to continue this check, I am going to just pipe it again, and I'm going to say get user. Okay, so we're going to get user, right? And then we're going to pipe, we're going to pipe once again, right? Now we are going to get email. Beautiful. Okay, so now I am expecting, I forgot the bang here. So let me just add this real quick, There you go. Awesome. So what I'm doing, I am making sure that all of the variables are filled with data. Else, no, I'm not going to send this to IPFS. Okay, cool. Now, if that's the case, guess what? I am going to return, right? What am I going to return? I am going to pack everything. I am going to grab all those values and add properties because we need to have a property reference to the value. Okay, so in this case, I am going to show you, and you're going to see now. I want to reference the name to the var. Okay, let me explain. So when I want to read the information from IPFS, I am expecting to read get first, and the response is going to be what? John. You see what I'm saying? So what I have to do, I have to stringify this in JSON. So I have to convert and wrap this entire input data into JSON because I need to have the name of the property so then I can retrieve the value of the property. If we don't have the property, how am I going to find the right information? You see what I'm going, right? So I have to make sure that I have this formatted in JSON so that we do the proper call. Okay, check this out. It's going to be very simple. So what I have to do right here, I have to say constant data. I'm just going to call this data. And I am going to say JSON. This is how you convert this into a JSON format. Okay, and we're going to stringify, right? Meaning that I want to make sure that this is a JSON string file, which is going to have the property name and the value. Okay. And now what I have to do, I have to open here, and inside here, I have to provide the properties which will be used. And by providing the properties, the JSON stringify is going to be smart enough to understand that that's the property name, and the value that is inside the property is the actual value. It's the data, okay? What I have to do, I just have to type each value or each variable again. Get first, get last, okay? Comma, everything after a comma. Get user, get email, and we're done. Cool. Now with this, I can send data to IPFS, and data will store everything: the first name, last name, username, and email address. Okay, let's go. So what I'm going to do, I am going to say constant add it or added. Let's just type this added, right? And we're going to say await what? I forgot that we need another function. Okay, I believe we need to tell first IPFS, the IPFS node, that we are going to be sending a JSON file. Okay, so what I have to do, let me do this real quick. We are going to create another file. This is going to be very quick because this is going to be used across the board. Okay, let me just do this. I am going to call this Web3 Connect.js because all my Web3 calls are going to be done here. And I have to just import the dependencies real quick. It's not going to take me long, and you are going to understand, don't worry. I am going to be importing client. Remember, client is the IPFS client, okay? So this right here, because we have exported it, we are going to be importing this into a Web3 Connect. So I'm going to say import client. There we go. We got the full import. Now let's build a function in a constant so that we can interact with that function in the index.js. Check this out. It's going to be very straightforward. Export constant, name of the constant, or in this case, the function, pin JSON. Let's just call this pin JSON to IPFS, which basically, this is the function that we are going to use to send data to the IPFS node that we have configured, okay? And this will be equals, and is an async, of course. And we are going to pass data from index into the Web3 Connect. So remember data, the constant that we created that stringify all the JSON details, I am going to be sending that data into this function, but this function is on a separate page. But you're going to see that this is very, very cool, and it makes the code very clean, super clean, okay? So I am going to send what? I am going to bring data here, okay? And we are going to then build the function itself. The function is going to be as follows. It's going to say constant. We are going to add data, okay? So we are adding the data. I am going to say what? I am going to await client because I am going to call to IPFS. Now I am going to pass this to IPFS, okay? Dot add. What am I going to add? I am going to add what? The data. This is how we are effectively passing the data to IPFS. Remember in the beginning when we built the IPFS node, added some characters and clear text. So I added like a sentence, but in this case, we're adding data, which is the entire JSON file that we just built in the index.js, okay? So I just added that, right? And now what I have to do, I need to obtain, check this out, I got to obtain the CID file that gets generated. Remember in the script that we built to test that it popped out a CID? That's the file that I need to obtain, or that's the value, because I need to send that to the smart contract, okay? So let's go ahead and do that. Constant, and we are going to call this path, okay? We're going to say path. Now I need to expect the response from added. Remember the first line, it's added. So once we await and expect the response from that promise, it's going to give us the CID. The CID is going to be referenced in path. So this is how we are just taking that single value out of the response that we will obtain from added and call this path. And then I'm going to return the value to index.js. Check this out. I'm going to type added, okay? What? Path. You can see right here, okay? So added path. Awesome. Now that I obtained the CID, this is how I was able to send the data to the node. I got a response with the CID value. I need to send this value to index.js because that value will be used to do what? To send the CID information to the struct in the smart contract. Okay, let's do it. Return path. And we have return path. Now I can use this file or this function in index.js because I am exporting it. Okay, I am exporting the function. Check this out. I'm going to control S. Now we're going to go to index.js, right? And I have to import that function. So I'm going to say import pin JSON to IPFS. Remember, this is what we just built. And now I can use this here, right? Remember added, which I was invoking earlier. Now I can call this pin JSON to IPFS. I am going to type pin JSON to IPFS. And what I need to pass, data. Boom, this is the data, okay? When I pass the data here, what's gonna happen? This is an imported function. What it's going to do, this, whatever is stored here, which is basically this stringify with all those details, I am sending it to this file, which then lands here. You see, this is how we pass data between different files, okay? This is how we make this application very clean. We are sending data from index.js, which was retrieved via HTML when the user typed the username, first name, last name, password. We send that to data, and then now data has been converted into like a JSON format, and then I will be passing it to the Web3 Connect, okay, as a prop. So we send that data here. Now we are effectively importing this function into the index.js. Now I can pass this along, and it's basically just going to this file and then throwing it here, calling IPFS and sending the data, and I should obtain the CID value back. Awesome. All right, let's go back. Now, once that's done, check this out. This is what we're going to do. Once that's done, I can build the function that will send the CID and build that user account in the smart contract, okay? So let's go ahead and do this for now. I am going to do console log, and we're going to type added, okay? Cool. We're going to Control S, and let's go ahead and try to see if we can talk to IPFS. Okay, so we got to make sure that we have this. This is looking great. Everything looking good. And Web3 Connect, it should be looking good. Awesome. Perfect. Let's give it a shot. Let's see what happens. Now, if everything went well, I should obtain in the HTML console the CID path to IPFS, and then we can check in the console ourselves or in the browser ourselves. Okay. So what I'm going to do, I am going to reset here. I'm going to type in God Smith. Okay. We're going to say S Smith. And then finally, I am going to type S Smith at a3b.io. Okay. If I hit update, this should go to IPFS. Oh, ho, 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 ho. There you go. Awesome. Okay. Now let's see what the data is about. Let me copy this, and we are going to confirm with our node that we can see the data here. Okay, so let's go into the node itself, HTTP, and we're going to type the IP address 2032.80.80. Remember, that was the gateway address. And then we're going to type IPFS / and the CID, and boom, boom, boom. There we go. Awesome. So now we have the data. It has been successfully passed to IPFS. Now, after doing the integration to IPFS, and we have successfully tested that we can pass data into the function and we can see the information in IPFS, now it's time to send the information to the smart contract. Now we need to pass the CID to the smart contract so then we can officially store our first user account. Okay, let's go ahead. What I'm going to do, I am going to invoke Web3 model so then we can connect the wallet and we can obtain the wallet address of that user that just connected into the portal. Okay, once we get that, I need to then send the information, the CID, along with other attributes such as the wallet address and the pay wallet. This is the internal wallet that we will be building, or we will be generating when the user builds its account. We're not going to be generating the wallet, the new wallet, in the last video. The next video, we will do so, and we will finalize the entire application. Now, what we want to make sure is that we can store user profiles in IPFS, and then we can see the profile in the web front end. Let's go and build this real quick. So for that, I got to do the following. Remember Web3 Connect? What I need to do now is that I am going to build another function. This function is to invoke the Web3 model so then the user can connect their wallet into the platform, and then we obtain the address of that wallet, and that is quote the account or the information for that user. So we will reference the wallet into the user profile struct in the smart contract. Okay, let's go ahead and do it. So now what I have to do, I have to bring Ethers, because we're going to be interacting with Ethers. We have to bring up that user smart contract, and we need to send calls into the blockchain. Okay, I'm just going to import Ethers. Okay, let's go ahead and import Ethers. There you go. Awesome. We have to export this function. Export async function ETH connect. Let's just call this ETH connect. Okay. Okay. So now what I have to do, I have to invoke the Web3 model. So then when the user hits the update profile, it opens the MetaMask wallet and the user connects into the platform. We grab the wallet address and we send that wallet address into the user database smart contract when the user populates the field with the user profile info. So the first thing I'm going to do, I am going to invoke constant. So I'm going to create a new variable called Web3 model. And this basically what it's going to do is going to generate a new connection using the Web3 model. Okay, so this is how we invoke the wallet. Okay, we will use this to open the wallet and request to connect. Now we are going to say constant connection equals, let's now, once the user connects, let's get the information from that wallet. Await Web3 model, and what am I going to invoke? Connect. Now we are effectively making the call, and this right here will open the wallet and prompt the user to connect. Okay, awesome. Now we have to do a provider. So we're gonna invoke a provider, and this provider, it's going to be injected into Ethers. So we are going to now use EthersJS to interact with that user account or with that user wallet, okay? So what I have to do now, I have to say Ethers, right? And we are going to say providers, okay? And we are going to say Web3 provider. This is how we tell that it's going to be a wallet or a browser-based wallet. And then we will tell connection. So I'm telling Ethers, hey, by the way, we have a Web3 provider. It's the connected wallet. In this case, this right here. Okay, cool. Now we need to obtain the signer. So the signer is basically the user's wallet. And with that, we can send transactions using the user's wallet. Okay, what we need to obtain from this particular function is just the wallet address, because we need to send the wallet into the user database smart contract. So then we can reference the information for that user to the wallet. Okay, so we're going to say constant, and we are going to say signer. Okay, and now we are going to invoke the provider that we built previously, and we will call get signer. And this is how we obtain the information from that signer. From this signer constant, we can actually obtain the address of the wallet, okay? So what I'm going to do, I am going to constant, and we will obtain the value in hex, and we have to convert that to string. So first, what I'm going to do, I'm going to create the address raw, which is basically the hex value of the address. And you can do all this conversion in one liner, but I just want to show you how can we convert this into string with two variables, right? So in this case, it's going to be signer get address, and this is how we obtain the hex value of the connected wallet address. Okay. Now I got to say constant, and we are going to convert that wallet into a string, so then we can pass this to the smart contract. And we're going to say address str equals. Now we need to say await, because this is a function we need to first await the user to approve connecting the wallet, so then we can obtain this information, okay? So we're going to say await address raw, which is the value that I need to convert, right? And we are going to say value of and done, okay? So now with this, I am effectively converting the format, or I'm expecting that output to be a string. With that said, I can effectively return address string. Okay, so check this out. Awesome. So now what's going to happen is the following. The user is basically going to, so we are invoking Web3 model. Then Web3 model, we will invoke the action to connect. This will prompt the user's own wallet to be connected into the platform. We then will pass to EthersJS providers, and then we will tell that please use this wallet as the provider. And from here, we are going to obtain the signer, which inside the signer, we can get the wallet address. And then we pass the value from this promise and then return it here. You can also do this. You can do await and then instead obtain it here. And this should return the wallet address in a string format or in the address format, okay? Now, when I do return, I can then import this function into index, and then I can obtain what value it's going to be generated out of the call, okay? So let me Control S. Now we're gonna go to index, and guess what I need to do? I am going to either import it up here, or I can even call the function, and NextJS is smart enough to auto import it for us. You're gonna see that now. So now that we confirm that we were able to add the data, the user details into IPFS, let's do this. I am going to change the name here to be a CID, because what we obtain from this call is a CID. We pass the data, we send that data to IPFS, but then IPFS will give us back the CID of the data that was passed, okay? Now let me just delete the console log. Now what I need to do instead, I have to await, okay? Check this out. I'm going to await, right? I am going to call the user contract. If you remember earlier, we built that user contract, which basically invokes the contract, right? Ethers contract function. It passes the smart contract address, the user ABI, and the updater. The updater is who? The updater wallet. This is the internal wallet that we have configured, and we provided the private key. So then it does the call internally, because remember, the updater wallet, it's the only wallet that can write into that smart contract, okay? So if we go back, now we already imported this user contract. Let's use it. Now we are going to call that user contract, okay? And now what I need to do, I am going to finally call create profile. This is the function in the smart contract, the create profile function. Let me show you real quick. You can see create profile. This is where we are actually going to pass the user account, okay? And you can see under create profile, we are going to pass the CID. The CID has to be generated first. Remember, I told you we have to generate the CID because we have to send the data to IPFS. We have to obtain the value, and then we have to store the CID into the smart contract. We pass the CID, we pass the wallet address. This is the wallet address of the user wallet connected into the application. This is the MetaMask wallet. And then pay ERC wallet. This is the wallet that we will be generating, but we're not going to do it on this video. I am going to let this for the last video. We will generate those ERC wallets. And when the user builds the account, we are going to generate a new wallet and assign to that user. Okay, cool. All right, so we got create profile. This is the function that we need to invoke in EthersJS. So what we're going to do, type create profile. Awesome. Now, what information do we need to pass to this function? If you remember in Remix, is expecting the first information is the CID, the second information is the wallet, and the third information is the pay wallet that we will be generating. Because in this demonstration, I'm not building that wallet. We are just going to pass this twice, okay? Just to test. But then on the last video, we will definitely do this, okay? So let's take a look at this. Now we saw the first thing I got to pass is what? CID. If you can see it, this is what we generate previously when we talked to IPFS. Awesome. Then what I have to do, I am going to be passing the user wallet. And this is the wallet address of the wallet address that got connected onto the platform. So the wallet, the MetaMask wallet that got connected into the application, this is the wallet that the smart contract is expecting now, and as the second value that we need to pass, okay? So with that said, I need to make sure that I obtain those values first. So I'm going to call constant, and let's call this connected. So this is the connected wallet, okay? And I am going to now await it connect, and you can see right over here, it auto imported the function that we just configured here in Web3 Connect. Okay, awesome. So because I am going to store that in connected, that's the name of the constant, it should provide me the address of that user, or in this case, the wallet address. We're passing that to that constant. So to this one right here, okay? When we do this, right, now we can effectively pass this as the second value that the smart contract is expecting. Cool. And finally, the pay wallet. Because we're not going to be generating the pay wallet yet, I'm just going to do a comma and pass the same connected, just to test, okay? But then we have to circle back and go and modify this once we are ready to generate those wallets, okay? Cool. Now, as a final step, we want to tell the user that the profile got updated, like a message. And we can pass this into the DOM as a text so that it can be displayed in the front end. Okay, so let me do the following. I'm going to type let confirmation equals, and we are going to say profile updated. Okay, and now I have to pass this text to the front end. So what I'm going to do, I'm going to show you the front end. So in the front end, what we are going to do, let's say profile updated right below here. So when we type the information and we press update profile, we should see update profile updated right below here. Okay, let's do that. Let me go back. Okay, and let's find that profile, outdated profile. Let's see where that information is. Profile info. There you go. Awesome. Now, below profile info, you saw that in the front end right here, we are going to add a message. So when the function completes, it says profile updated. Okay. So what I'm going to do, if you can see right here, I assigned an ID to a header. So header 5, I assigned the ID of display update changed. Let's use this to pass this value. Once the function completes, we should see profile updated below profile info, okay? So let me show you. Below here, we should see profile updated once everything is complete, okay? And let's go, and it's gonna be display update changed, okay? So let me go up, and profile updated. Now we have to pass that value. So we're gonna type document, get element by ID. Again, we're obtaining this value, but now I am going to say display update change. Let me just copy this, right? And we are going to pass this over here. Display update changed. And we're going to say inner HTML, okay? And this will be equal to what? To confirmation. This is how we effectively pass this to this ID. We will pass this message to this element ID, okay? Let me go ahead and Control S, and we should be good. We should be good to create our first profile. Okay, let's go ahead and type a user account, and we should see the wallet opening, asking us to connect, and then we should see profile updated, because that basically grabbed the information from the wallet. It passed the information to IPFS. It generated the CID. And yeah, we should be good to go. Okay. So as a matter of fact, you know what? This is what I'm going to do. I am going to add a console so then we can find the CID, right? And then we can compare the value to the smart contract. We should have stored the CID into the smart contract, okay? So I'm going to Control S, and we can just validate in the console, okay? All right, so let's type the name. It's going to be Robert Smith, R. Smith, and the email is rSmith@a3b.io. Moment of truth. Let's see how that goes. Boom, already got the wallet opened. It's asking me to connect with the MetaMask wallet. Let's click next and connect. Let's wait. Boom, we got profile updated. Awesome. Let me see. Now let's go into F12 and look at that. We got the IPFS CID. Awesome. Let's validate that the user account information, it's now stored in IPFS. So let me go to the node. We already got tested with this. Let me just replace the CID with the new one. And let's see. Beautiful. Robert Smith, R. Smith, A3BIO. Now let's go to the smart contract and see if the user account has been created. And we want to find the information for this account. So let me go now into my wallet, right? And I am going to copy the address. So I am going to copy the address, by the way. It should be showing connected here. And let's see. Yep, it shows connected. Awesome. So I'm going to copy the address. Now let me go under Remix. And let me paste the address right here and see what we show. Oh, awesome. Remember, user ID and pay wallet, we just passed the same value, okay? Now the account CID, is this the same value that we saw in IPFS? Let's confirm. Copy. Let me open a new tab here. And 10, 10, 20, 32, 80, 80. IPFS, and now let's paste this in and see. Ha 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 ha. There you go. Awesome. Now that I have this information, guess what I need to do? I just need to call this account, right? So the moment the user connects their wallet, I can read this account, I can get this information, I can call IPFS, and I can obtain those values and place those values in the front end. So once we are done with that, okay, now the user should be able to connect their wallet, or we are going to auto ask the user to connect their MetaMask wallet. Once the MetaMask wallet gets connected, we will show the information in the front end. Alrighty? On the next video, I am going to finish the entire app. The user will connect their wallet. We are going to show the user information. We can generate wallet addresses, and we will provide the ERC20 tokens. We will finish this amazing application, okay? All right, so that's it for this video. In the last and final video, we are going to be generating ERC wallets. And every user that creates a user account in our beautiful web profile app is going to obtain 250 custom ERC20 tokens. We're also going to be deploying a ERC20 token smart contract that will be interacting with this application, which we will auto mint on the fly those ERC20 tokens and deposit those tokens into the user wallet. But this is not the MetaMask wallet, as we mentioned. This will be a wallet that we will be generating. You are going to learn how to generate ERC20 wallets, and we need to store those wallets in a very, very particular way, because I need to interact with that wallet. Every time that I need to withdraw funds from that wallet, I gotta have the rights to do so. This is a wallet that will not be controlled by the end user other than withdrawing funds, okay? Or making purchases into the platform. Anything that the user wants to do, they can use the internal wallet for that, okay? For us to then withdraw the funds or transfer the funds to the user wallet, to the MetaMask wallet, we need to do some magic, okay? We are going to learn all that, okay? Alrighty, so that's it for this video. Boom, boom. I hope you liked this video. And if you do me a favor, hit the thumbs up, subscribe if you haven't subscribed to me. Hey, and we'll see you on the next video.